In the previous video, we looked at a derivation for sine law, what it looks like. Now we're going to apply it. So the scenario here is you have Los Angeles and you have Phoenix, and there's a satellite. The distance between LA and Phoenix is 340 miles, and these three points form a triangle. The satellite, as viewed from LA, the angle of elevation is 75 degrees, and as viewed from Phoenix is 60 degrees. And the question is, how far is the satellite from LA? So we're trying to find this particular side. First step is I'm going to change this into an appropriately labeled triangle. Keeping all the orientation the same, I'm given small a, which is 340. I'm trying to find B, 75 degrees, 60 degrees. So what do we know? Let's list it down. What is given to me is angle C, angle B, and side A. What am I trying to find? Is small b. Now let's do the solution. Now the easy part would be to find. Let's first write the sine law. A over sine A, B over sine B, C over sine C. What do we know? I know A, I know B and C. So if I were to use the first two, I only know two things. If I use the last two, I only know two things. If I use the first and the last, again I know two things. But our life gets a little simpler here because I can find angle A because it's a triangle. Angle A is 180 minus B minus C. So it's 180 minus 60 minus 75, which is 120 minus 75, which is 45 degrees. So I actually know A. Now, what we're trying to find is B, which means it makes sense to use the first two terms of the equation. So let's do that. So I have 340 over sine of 45 degrees equals B over sine of 60 degrees. I'm trying to solve for B, so I multiply both sides by sine 60. Just to write it out, this is going to be sine 60 degrees multiplied by 340 divided by sine of 45 degrees. And to evaluate this accurately, you can just punch it into the calculator as it looks right now. So I'm going to use parenthesis sine of 60 times 340 divided by sine of 45. It comes out to 416.41 miles. So that is the distance between the satellite and LA. Let's look at another example. In this case, the triangle is already given to you. The two angles are given, and it says solve the triangle. Solve the triangle means all three sides, all three angles. It means find both of them. Okay, so let's see. What's given to me is side length C, angle A, angle C. I need to find side length A, B, and angle B. Let's do the easiest one first. Angle B is 180 minus angle A minus angle C. 180 minus 20 minus 25. 180 minus 45. 135 degrees. So done with that. Now, so it looks like in this situation, let's see what do we have and what we don't have. I have this, I have all three angles, but I don't have these. So using the first two is not going to help me because there are two unknowns. But I can use the last two. Using the last two, I get b over sine of b, that's the angle I just found, equals c, given to be 80.4 over sine of c, which is 25. Again, since I'm solving for b, I multiply this by sine 135 on both sides. So b is 80.4 times sine of 135 divided by sine of 25. Punch that in the calculator. I get sine 135 times 80.4 divided by sine of 25. That comes out to 134.52. Okay, now I know b. To find a, I can either use first and second, or I can use first and last. So I can go a over sine of a, which is 20 degrees, equals 80.4 over sine of 25 degrees, giving me a is 80.4 times sine of 20 degrees over sine of 25 degrees, which is 80.4 times sine of 20 divided by sine of 25, 65.07. Or I could have also used a over sine 20 is this new b value that I found, 134.52 over sine of 135, which would mean a is sine 20 times 134.52 divided by sine of 135, which you would hope is going to come out the same as what we have here, because they're equivalent methods and they should give me the same answer. Sine of 135 also comes out to 65.07 roughly, which makes sense. So the point here is that after you find one of the sides, or after you have reduced the number of unknowns by one, there can be multiple ways of finding the remaining unknown things. You can use one set of equation or the other, and in either case you're going to get the same answer. So that's all for this video, which is examples of application of sine law. Now a very specific example arises, which we discuss in the next video.